Good morning, my YouTube viewers. It is Crystal here. I'm here this morning because I wanted to give you a code review. And this code review is going to be on London Airbnb prices. And it's going to be natural language processing and numeric at the same time. And so what I've done is this is the first time I've done this. And one thing that I would like to say is when I have taken the TensorFlow courses, they only tell you how to make a prediction on one type of data. So in order to make a prediction on more than one type of data, you have to go through and search the code. And so I did try ChatGPT. I did try to get the code from ChatGPT, but it wasn't really very good. And so I did get the code from Stack Overflow. So basically now with my code, you'll have two pieces of code that's good that you can use to make predictions on natural language processing and numeric at the same time. And I hope to expand upon this to learn how to do more pieces of code when I can. So what we're going to do now is we're going to do the code review. And this was a Kaggle competition, a Kaggle community competition, and we are on Airbnb prices, so it's a regression model. And my best score was 72. My first score was 78, but I made a few changes. And then after I made the few changes, then I improved the score up to 72. But it was a very difficult competition to enter because you have two pieces of data that you have to make predictions on. And as I said, when you take courses and things, they only teach you how to do it on one piece of data. So you have to figure out how to do it on the two pieces of data on your own. So that's one thing I'm going to be experimenting with more, is making predictions on the two pieces of data. So I've written the program in Kaggle's free online Jupyter notebook, and I created it. And one thing that I will do is I will leave you a link to the code so you can look at the code if you want to. So after we've created the notebook, the first thing that you want to do is you want to import your files. So we're going to import NumPy as NP, which creates NumPy arrays and performs mathematical computations. We're going to import pandas as PD, which creates your data frames and performs data processing. We're going to import OS, which goes into the operating system. We're going to import sklearn, which provides machine learning functionality. We're going to import TensorFlow, which creates your neural network. And we're going to import matplotlib.pyplot_splt, which visualizes your data. And then we're going to import seaborn as SNS, which visualizes your data statistically. So after we have imported the libraries that we need, we're going to get the files. And so we're going to use OS to get the files. And they've given us 3 files: train, test, and reviews. And please note that we didn't get a sample submission file. So that means we have to create the sample submission file. So after we have used OS to get our files, we're going to use pandas to read those files, and we're going to read them in as train, test, and reviews. So here's your train file. And one thing about your train file is your price is your target, and it's not at the end. It's not the last column. It's in the middle. We check info. So you see you've got a lot of objects, view integers, and some floats. And you'll see somewhere in here you've got your price. Number 30, you've got your price. And that's what your target is. So we're checking for null values, and you've got lots of null values. So those null values are going to have to be taken care of. And then we have our test file. Our test file is similar to the train file, except it doesn't have the price, which is the target. So that's what we have to make predictions on. And then we've got our info. So the info is the same as it was in the test file, except for the fact that there is no price. We check for null values, and we've got lots of null values that are going to have to be imputed. So that's something that we're going to have to deal with. And we check reviews. Now reviews are the comments, and your comments are going to be your natural language processing. So we're going to map the review into train and test. So train comments equals train listing ID dot map dict zip reviews listing ID comma listing reviews listing ID comma reviews comments. So that's how we did it to get it to work. So you had to map it in there. And then we did the same thing with the test file. It's exactly the same code with the test file, except it's test and not train. And that's what I had to do to get it to map it there. We mapped it in as a dictionary, and that's the code that you can use. So now what we're going to do, we're going to check if train and test are from the same distribution, and I checked that, and nothing happened. But we're going to check the target. So this is your target. This is what your target looks like. data trained tensor. And now we're going to get the sequence length. T equals NLP train dot shape 1. And so now we're going to say NLP test equals pad sequences. Sequences test math plan equals T. And then we put the shape of the test tensor as well. So now we have another bit of code. Data train equals NLP concatenate NLP train numeric train axis equals 1. Data test equals NP concatenate NLP test numeric test axis equals 1. So we create the data train and data test where we concatenate the NLP train and NLP numeric. So now we're getting to where we create the neural network. So the embedding dimensionality is G is 220. Hidden state dimensionality M is 40. NLP input equals input shape T. Name equals NLP input. Meta input equals NLP shape equals numeric train shape 1. Name equals meta input. ABnB equals embedding B plus 1 D NLP input. M equals ABnB equals bidirectional LSTM 64. Return sequences equals true ABnB. ABnB equals dropout 0.20 ABnB. ABnB equals bidirectional LSTM 128 ABnB. NLP out equals dropout 0.2 ABnB. And now we're going into the numerics. X equals TF concat NLP meta input 1. X equals 1064 activation reclude X. X equals dropout 0.20 X. X equals fixed 1. Activation equals linear X. And then model equals model inputs equals NLP input, meta input, outputs equals X. And then we're going to set up our optimizer. Optimizer 1 equals RMS prompt. Learning rate equals 0.0001. So now we compile and pick it. Model.compile. Loss equals mean squared error. Optimizer equals optimizer 1. Metric equals MSE. So now we're going to get into the training. So we're going to set up our early stopping and our model checkpoint. And history equals model.fit. NLP train and the numeric train. Target epoch equals 5. Stack size equals 32. Validation split equals 0.2. Callbacks equals early stopping and MC. And we only trained it through 5 epochs because it took such a long time to do it. It took about half an hour to train it for 5 epochs. And so now what we've done is we've created a graph. So we created this graph so you can see what the loss is and the MSE. So now we're going to predict on the test set. Predictions equals model.predict. NLP, new test, numeric test. Predictions equals predictions faction, predictions. So you can see that you got your predictions. And then what I did was I used C1 to make a histogram of the prices. So you can see the prices here. And then we prepared the submission. And basically what happened was they didn't provide a submission file. So I just had to guess. So I guess ID listing would be the first column and the price would be the second column.
dyslexic